not a single issue, so single thing. So it moves towards around 60% of electric vehicle in the sense automatically infrastructure, that is charging stations, and also other researchers are is a sub byproduct components. So mitigation of harmonic issues and the development of a battery technology and the grid stability. So these are all the additional component moving towards the development of electric vehicle technology. So if I take as an Indian market scenario to forecasting about 2025, so starting from a two-wheeler E2 vehicle to an e-bus. So first thing is starting with an two-wheeler and then move to a rickshaw, then to an auto, then to a passenger vehicle for wheelers, and now moving towards an e-bus. So the trends are now changing. So starting from a two-wheeler, so two-wheeler almost, so it reaches about a 75 percentage, moves towards the development, and likewise the rickshaw also they are coming with the electric EV technology. So only one thing is if infra charging station is getting established in a full-fledged manner, and also the battery swapping technology is now also moving in a trend. So lithium-ion battery are playing a major role nowadays. So we can able to make a 200 and 300 kilometers per hour for a single charge, and if you make a swapping, almost it reaches to 160 kilometer like that. So the Indian market scenario is now in a good trend. So now e-bus, the development is towards in a long way. So in 2040 or 2035, so starting from 2020, so the development is in a long way. So a number of research opportunities are in a power converters to forecasting and to also interfacing the renewable system and also interfacing a source to a load end. So again, forecasting Indian market scenario mass product, mass production. So 42-volt hybrid electric vehicle is playing a predominant role when compared to another sector. So battery operated and plug-in vehicle, which comes under an electric vehicle category. So in the graphical representation, so total EV market from the year of 2015 to 2020, electric vehicle, plug-in electric vehicle. So these are all These are all the key plays nowadays. These are all the trust and booming areas nowadays. So if I take as an entire scenario, so the development towards battery technology and the power converters are the key components. General blocks of an electric vehicle, battery technology and power converters are the heart of the electric vehicle. So others are auxiliary components. So other components are already available. So electric motors are also available. So BLDC motor and DC series motor. So I will discuss types of drives in the upcoming slides. So these are all already available components. But only one thing is so changing in a topology of a power converters and adaptation of battery technology. So here the battery technology is related to a fuel component of an IC engine, and the wall systems are related to a power electronics. Ignition systems are related to a power electronics. So without power electronics, the entire scenario is in a question mark. So this is just a scenario towards an Indian market. So Hyundai, they are launching their vehicle 452 kilometer on a single charge with a battery of 39.2 kilowatt hour. These are all web data is available in our web. So Mahindra for a single charge is a 140 kilometer on a single charge. So rate comes up to 12 lakhs like that. So Mahindra E2O is they're launching. So for a few testings, the problem towards the battery testing. So at the time of initial torque, due to high initial torque, they have a probability of bursting of a battery vehicle due to a sudden discharge. And in some cases, so the shaft of a particular four-wheeler or two-wheeler, that is four-wheeler or rickshaw, if it is directly connected with the electric drive, automatically there is a major problem to face, major problem facing for a testing of an electric vehicle. So for that, there have some gearing arrangement along with the vehicle search, and it moved towards the gearing arrangement with the proper propulsion ratio. So these are all electric vehicle dynamics. So this is an entirely different area. It needs some design and calculation on what way we have to make it in a good manner, the proper ratio, and how we can maintain electric torque, that is motor torque with the load torque. So automatically, if a motor torque is equal to a load torque, automatically the system will come under stable. So here we are talking about electric motor characteristics. So that is an important parameter. So Mahindra faced a lot of problems 1 year back. So they have tested their vehicle in India, that is Chennai. So they have faced so many problems. Now they are coming forward, and they have launched so many vehicles, and with a single charge 150 kilometer. So the cost around a nominal of 7.46 lakhs with the subsidy of Indian market scenario. So they are all the key players. A number of key players are now available from a Tata, Mahindra, Hyundai, so Kia Motors, Ashok Leyland. So they have a number of series are available. So Trigo, so they are launching their electric car and ultra electric bus. Now that thinking about the technology, that is thought towards the technology is a wide, that is towards the long run we are thinking, not starting from it now. 2 or 3 in 4 5 years back we are thinking about a two-wheeler and auto rickshaw. Now we are thinking about move to an ultra electric bus. So we are thinking in a wide way. So surely it will reach a market within a couple of years. So again, these are all the upcoming electric cars in Indian market scenario. So so if you take as an Audi, so they are launching their e-tron, so is under market with a higher end. So in that all the sophisticated features are now available with an Audi. So like that, likewise, if features are getting improved, automatically the comfortness for a particular vehicle also getting improved when we compared with another technology. So each and every ventures they have their own way, and they have their own development of their power electronic component and electric drives. So if it go for a electric powertrain scenario, so if you take as a year of 2020, that is up to a 2020, the development is 35 percentage of that power electronic components. So if you take as an Indian market or electric general scenario, nearly 30 to 35 to 40 percentage of particular percentage comes under power electronic drives. Since it is a part of an electric vehicle, without a development or without a comfort zone of a particular power electronic devices, no one can survive or no one can develop a particular system in a so the development of the power sector, power electronic sector, now moving towards an electric vehicle. So another one challenging task is how we can interface or interconnect the renewable energy resources, the electric drive. So that is also a separate area now we are doing. So if it is connected with the renewable energy or solar, that is the solar is the best renewable energy along with the fuel cells also now they are equally competing. So if all the energy sub energy resources are connected, it comes to a particular scenario like that multiple input single output scenario. So the interfacing medium or interfacing agent is an power converters. So it gives their key players in an Indian market scenario. So if you take as this is a hybrid electric train. So here they have a interconnection between a mechanical parts and an electrical parts. So if I take as an electrical scenario, battery pack, there is an important component. The battery pack is linked with a mechanical transmitting system through a mechanical coupler. So the way it is connected with a mechanical, with an electrical, is through a power electronic devices. So power electronic devices, it plays a major role while interfacing a particular medium or that is electrical, mechanical to an electrical medium. So I hope through a web I was familiar about parts of an electric vehicle. So if you take as a parts of an electric vehicle, the major parts it comes to a converter and inverter side and electric motor, along with the mechanical scenario. So if you take as an main parts of an electric vehicle, one is electric traction motor, that is called as an electric drive. So it plays a major scenario, it plays a major role. And another one is a power electronic controller. So controller, number robot boss, and they are all the key players to connect to interface their controller with a particular converters. So controller, their function is to control a converter, not directly with the motor. So controller can't control the performance of a motor in a direct manner, but it is a rolling, it is a key player to control a converter and to in turn which converts the electric drive. So DC to DC converter, so it depends upon the topology what we are using and how we are configuring, what type of drive you are selecting. So that comes under different topology. So if you take example, if you take a Tesla and also accuracy of Tesla. So the key component, if you take as a Tesla vehicle, is a high starting torque. So they are focusing on a high starting torque. So they are choosing in a two different types of drive. So one is with the DC series drive, DC series motor, and the other one is a three-phase induction motor drive. So each and every vendors they have their own key features, they have their own identity and uniqueness. What way we can connect and what way we can superior to other superior to other vendors and how we can utilize the technology in a better way. So each and every vendors, so that is obvious. So they want to have to substand their market via electric vehicle. So they are ready to they ready to build any type of vehicle with any technology. So risk assessment, they are ready to face that. So without any risk, no one can survive, no one can develop. So that is a general aspect. So if you take, likewise, if you take as an electric vehicle, handling of battery technology, handling of battery is one of a risk parameter. So for that, they have a number of charge controllers, charges are also charge controllers and also controller also available. So if you take as a electric vehicle, so DC to DC converter is important parameter to handle the power flow from a source end to a load end. So source end, that is called as an battery. So want to make a power conditioning of a source to load. So DC to DC converter, it plays a major role. So likewise, if they have a traction motor, so what type of motor we are choosing, based on that we have to choose the power converter. So application side plays a is a influencing factor to choose a particular converter topology. So if you're going for a Tesla, they are choosing an inverter. So if you go for an inverter directly, we can choose a boost inverter. Like that, they have a certain topology, certain specification. We have to make it as an key point. For that, we have to select as a drives, that is drive and invert, that is converter or inverter like that. So based on that, we have to select a battery pack. So in a battery pack, we have to focus only on a charging and discharging. So if I take as a converter, a number of topologies are available to interfacing a source to a load. So charge port and onboard charger and power electronics converter. So these are all the major parts of an electric vehicle. So in that among these, power controller or drive and power converters comes under the same category, comes under the same power electronic developments. So if we take as a key component of electric vehicle, power converter, controller, battery bank, and electric motor. So what we have to make, what are all the points we have to consider while making as an or while developing an electric drive or while choosing an electric motor. So they have to, the drive have to perform forward motoring, reverse motoring, speed control and braking. So these three all the predominant process we are expecting from a particular drive. Of course, we are expecting from a now IC engine also. So one is motoring, whether it have a good starting torque, whether it can start, whether it can move at any time. So like that, have a forward motoring. So without any oscillation, without any disturbance, whether it can able to start, move and forward. So whether we can make a reverse process at a instant or at a immediately, whether it can come back, or that is the reverse processing, reverse monitoring process. Then another important thing is we are expecting sophisticated and optimized control process. So this and all nowadays the development and the focus is towards the control of a electric vehicle. So forward motoring, reverse braking and all, reverse motoring and all easiest to process. So any drive, any type of converter, we can achieve it easily. But while moving to a closed path, that is the closed loop control, while making as a control, and it goes to, when it goes to a braking, whether we are moving to a rheostatic braking or dynamic braking, or it goes to an regenerative braking. So due to the development of a power semiconductor devices and technologies in an embedded field, regenerative braking are nowadays most popular. So when a speed is above super synchronous, automatically the power is spread from load to source. So these are all the key points we have to consider while selecting a particular drive or particular vehicle. So as a R&D research engineer, the vendors, as a we vendors also nowadays, so they are all focusing towards the development of our semiconductor devices. So various types of motors used in electric vehicle is the DC series motor. So I hope you're all too much familiar about the characteristics of a DC motor. So we are using this DC series motor for a traction. So no doubt at all, it has a high starting torque. So no doubt at all. So next, the peculiar motor is BLDC motor. So nowadays, the special electrical machines like BLDC motor, permanent magnet synchronous motor, switched reluctance motor. So these are all the motors that are developed in other technology, and these drives are all now in trending for the development of electric vehicles. So obviously the BLDC motor are apt motor for a electric vehicle. A number of, that is more number of vendors nowadays choosing a BLDC motor for their electric drive. So DC series motor, Tesla, they are preferring an induction motor drive and a series motor drive. So each and every vendors they have their different opinion and different thoughts. So based on that, they are selecting their drive. So permanent magnet synchronous motor also, they are choosing their own specification for a particular electric drives. So while considering or while choosing an electric vehicle or electric motor, not electric vehicle, electric motor, certain points or certain factors we have to take into account. That is vehicle characteristics. So that is very important point. So vehicle characteristics which comes under the dynamics of a particular vehicle. So if we take as an electric vehicle characteristics, whether a vehicle is running at an equilibrium point or not. Equilibrium point, without, if it reaches an equilibrium point, automatically the stability points it will occur. Stability it will occur. So when a motor torque is equal to one load torque, so that is the general scenario which comes under a drive's characteristics. So while selecting a particular electric motor, these 10 things we have to consider. One is the drive characteristics, another one is drive cycles. Drive cycles comes under 4-quadrant operation. Which quadrant, which cycle we are running. Another one is whether it is a continuous or intermediate and what way we are using. Whether you are preferring for a rickshaw or passenger, or if it go for a higher end vehicle, like that they have a driving cycles also. Then what type of configuration we are using, what type of topology what we are using, whether directly we are moving toward an electric vehicle, plug-in electric vehicle, or if you are going for a hybrid, whether with the IC with an electric vehicle or FC, that is the fuel cell with an electric vehicle, or some with a battery with a direct battery with an electric vehicle. So likewise, so what configuration is very very important. Then maximum speed and torque, power, these three are important. So maximum speed, how much we are expecting. So if you take us a two-wheeler, it speed is maybe it's up to 45 kilometer per hour. For particular application, it is more than sufficient. Why we go other vehicle like that? If a customer is satisfied, okay, but expectation gets different. If an expectation gets differ, the parameter also getting differ. So the parameter influence for a particular vehicle, it also get differ. Then maximum torque in the sense, I already told that if a drive is running at a smooth point, so equilibrium point is very very important. So the torque developed by an electric motor, it is connected with the shaft of one particular vehicle, so that shaft is connected with the four wheels. So whether we are moving in a four-wheel drive or is an individual, it has a particular inverter like that. So these are all the factors which moving to focus towards the maximum torque category. Then maximum power. So how much of power is required? So power is an important parameter which decides the battery and also battery capacity. So that and all a different area. So these 10 are an important parameters we have to consider while choosing an electric motor drive. So types of electric drives. If you take as the types of electric drives, I already told that BLDC, PMSM, induction motor, and switched reluctance motor. So each and every drive, so it has its own feature, own specifications. So while selecting a particular drive, so as an electrical core engineer or as an R&D engineer or any venture, so we have to focus whether drive is connected with directly with the shaft of a particular not that is particular vehicle, or it is connected with through and gearing arrangement. So these are all important parameters. What type of vehicle, what type of induction, what type of drive, that are all not a matter, that is immaterial. That depends upon a design characteristics. If we want to select a particular drive, so it needs, first thing we have to consider that 10 parameter, what type of drive we are selecting. So if a drive is okay, then we move to a power converters. Power converters is a separate part. So drive is a separate part. These two are interlinked for a particular applications. So whether it is a direct wheel drive or we have a gearing arrangement, if it has a gearing arrangement, then we have to focus the dynamics of a particular vehicle through a particular gearing arrangement process. So each and every electric motor drive, it has its own principle of operation. So if you take as a BLDC motor, so it needs a 6-switch converter. So while selecting power converters, so we have to choose a particular topology. So a single topology is not affordable, is not suitable for all the electric vehicles. So while selecting a particular power electronic devices or power converter topology, so we have to look into what type of drive we are choosing. If we go for a BLDC motor, it needs at least a 6-switch operation or S4 switch operation, 4 switch with 2 capacitors. So this and all now research is going on S4 switch. But if a BLDC with a 6-switch operation is already available in the market with the Ventas of Mahindra like that. So they have preferred in a brushless DC motor drive with a 6-switch operation. So if I go for a DC motor, so DC motor is directly we can choose any type of DC to DC chopper, or like that we can go for a direct chopper operation. If you go for an induction motor drive, the same scenario. But if you go for an induction motor drive, we have to focus about a rotating magnetic flux operation. So difference between BLDC and induction motor drive, the topology may be different, but the switching pattern is getting different. So like that, we have to make a key note of that, what type of drive we are using, what type of converter we are selecting. Then we go for a controller and battery technology likewise. Then we move to a Y power converters. So this is one of the topics. So far we discussed what are all the Indian market scenario and what type of drives, what is the importance of a particular drive and all. So now, why power converters? So in the pictorial, each and every pictorial representation, it clearly shows that. So it is a transmitting medium and control a power conditioning medium of a power from a source to load. So that is very, very important. So if I take as renewable energy resources, suppose if you are making as a solar based electric vehicle, then source is coming in the front end, that is a solar. Then we have to process the solar power conditioning of a particular solar, whatever may be a converter, but it needs a converter. So topology may be get differs, but a single term power converters plays a major role. To control a power converters, controllers plays a major role. So a number of technologies are now starting from a microprocessor to 8051 to nowadays they have a TMS processor like that, PIC and that mega. So whatever may be a processor, even FPGA. In that controller, we can moving towards soft computing technique. So controller plays a major role to control the converters. Then the power is transmitted from a source to load. Here load a shaft of a particular electric vehicle. So the shaft connected with the four wheels, it acts as a load for a particular vehicle. So converter, without converter, none of the powers are get transmitted from a source to load. One point. Another point is we have to achieve a three main operation. One is forward motoring, reverse brake motoring, or reverse braking, on control and braking. So these three important parameter or process or get achieved by help of a power converters. Then if you take as an electric vehicle, simple process, it is a control. So control of electric flow. That is the main important point of a driver circuits. So if you take as a driver circuit, so it controls the flow of electric power in that is electric motor. So that plays a major role. So if electricity flow of to a particular drive is get controlled automatically, the flow, that is operation dynamics, angular velocity of a particular wheel is get adjusted. So if a particular operation is get adjusted automatically, the ampere hour of a discharge of a battery also it gets tuned. So here battery charge is equal to a fuel. So fuel of a particular IC engines are get adjusted by a electronic technology. Likewise, so the flow of electricity from a flow of charge from a battery is get adjusted. So this is a block diagram of an electric vehicle. So generally, if I take as a battery bank, so battery bank connected with an electric motor unit. So through a power converter. So power converter it is get controlled by help of a controller unit. So each and every power converters it needs a power controller. So type and topology or the selection of switches that and all comes under different category. But without power converters, can't interface the source to a load. That is a battery bank to an electric motor technology. So for a battery, it needs a separate battery management technology. So battery management systems. So if I take as a DC to DC based electric vehicle, that is a DC series motor based vehicle. So if you are applying a pedal, that is the accelerator on a particular, so automatically the entire concept is very simple. A duty cycle of a particular controller is get differ. If a duty cycle is get altered, automatically a power converter units it gets altered or refined based upon their acceleration. So duty cycle is nothing but T on by T. For a particular total time period, how much uh, time period is in on. So that on is going to an in terms of percentage. If a duty cycle is 90 percentage, automatically 90 percentage of power is transferred from a source to load. So that is the general concept. So through a controller. So controller, if you want to make it as a closed loop and make it as a more system, more features with a sophisticated, so the controller it needs a closed path. So automatically, if you are applying, if you are making an accelerator in a particular position, so automatically it controller refers actual speed and a desired speed. We want to increase the speed to a particular limit of, for example, now the vehicle running at a 80 kilometer per hour. If you want to increase 80 kilometer per hour to a 90 kilometer per hour, automatically our controller it works based accordingly, and automatically the width of a converter, that is duty cycle is get altered. So duty cycle is 50 to 70. So automatically the vehicle now reaches to 80 kilometer per hour. So likewise, we can increase or decrease the speed of a particular vehicle. So if take as a DC to DC or the battery vehicle array, so the accelerator or a pedal sends a signal to a controller, so which in turn adjusts the speed of a particular vehicle by changing a switching frequency of the power. So switching frequency plays a major role for developing a that is a duty cycle of a particular converter systems. So if a battery is a 96 volt, in the sense the DC motor operated below a 96 volt through a controller. So based upon an accelerator, automatically the width of a firing pulse is get adjusted. So firing pulse in the sense triggering pulse of a particular converter. So this is the entire block diagram of a electric vehicle. So in that they have a differentiator. I hope you're all familiar about mechanical people familiar about a differentiator like that. So differentiator, so it it splits the power to a four wheels. So it may be a four-wheel drive or it may be an all-wheel drive. So like that, it may be a quattro like that. So if you are adjusting a steering, automatically the differentiator will work out accordingly, and it will split the torque equally to a particular vehicle, that is a shaft. So in that case, what are all the category? So it needs two inverters. One is the right inverter, another one is a left inverter. So that inverter is based upon a type of drive. It is a type of motor what we have chosen. So like that, it's split according to their category. So then battery. So whether it may be a lithium ion battery or it may be a lead acid battery. So it goes in a different manner. So then DC to DC converter. So DC to DC converter in the sense, so it goes to a boost operation. So block diagram of multiple input, single output. So MISO system. So here they have a n number of input. So input is more. That is fuel cell act as an input, supercapacitor act as an input, battery act as an input. So these are all the multiple inputs, but a link is common DC link. Then output is a single, that is to an AC to DC converter. So DC to AC converter. Here output is a single AC which is connected to an, whether it may be an induction motor drive, or if it is in a pulsating manner, it directly we can connect it with the DC or a switched reluctance motor. So likewise, we have to develop a system. So we have to choose what type of drive, what type of system we are to develop. It may be a single input, many out, multiple output. So that also there. So we will discuss in the forthcoming slides. So in this, the second block diagram, it represents an extended boost chopper with a supporting ultra capacitor. So for example, for a particular starting purpose, it needs some extra power. If you are utilizing extra power from a battery bank, automatically the entire operation is get affected. So we have to keep it in mind for such a case, for a occasional case like that, or for a starting case. For example, if you take as a grid system, we are talking about a maximum peak demand. So maximum peak demand, that maximum peak demand can be compensated by some electromechanical system like that. So likewise, so whether we may go for a wheeling concept or we may go for a renewable system concept for a, to compensate the peak demand. So likewise, we have to develop an extra system, this ultra capacitor system, to carry out the process. Then block diagram of entire electric vehicle. So they have a DC to DC charger or inverter, and series of battery banks are connected in a particular vehicle, that is particular stack. So battery plays a major role. After that, power semiconductor devices plays an important place while interfacing battery bank with the entire scenario. So if I take as an electric vehicle, power converters and battery banks are interrelated with each other to control to provide a maximum motor torque to meet a load torque. So for that, so if we need an regenerative braking concept. We need a regenerative braking concept. We need a bidirectional converter. So this is a very important point we have to develop in a consideration. We have to keep it in a consideration for developing a bidirectional, because when drive is under super synchronous speed or above rated speed, whatever may be a technological words we can use that. So at that time the power is transferred from a load to source, and uh, generically we can say that it is stored in a battery. Okay, but generally can, if it is develop, if it is forwarded, if it is come back from a source to load to source, anyway we have to store it, otherwise it will be get wasted. So likewise they have a regenerative braking concept. So in that type of category, we have to take most care whether a converter is in bidirectional system or not. So types of power converters. So converters, controller, motor, and transmission medium. So if I take as a the number of are already told that it's available. Then the devices IGBT, MOSFET, GTO, MCT, and BJT. So topology, the main topology, chopper, inverter, PWM, and resonant converter. Then if I take as an electric motor, so for electric motor, so that is for manufacture. So using CAD, the finite element analysis method, or thermal, likewise the analysis. So these are all the research opportunities available interconnected with an electric vehicle. So if we are viewing electric motor as it is an electric motor. But if we are moving to a research towards a particular system, it goes to a different versatile area. Then types of major types of power converters, already we are familiar about AC to DC, that is invert converter, AC to DC to AC, and AC to AC. So these two are a major type of converters used in an electric vehicle. So if you go for an inverter, that is voltage source inverter, current source inverter, and multi-level inverter. If you go for an AC to AC converter, it is a cyclo converter and matrix converter. In a matrix converter, they have a direct matrix and indirect matrix. So matrix converter, which comes under a wind energy conversion system, is not suitable for an electric vehicle. So it's directly without any DC link. So nowadays in a matrix converter, they have a DC link. It's a research is under the development of a DC link or interlinking a DC link with the battery systems. So for take us in a nutshell, so this comes under all those things, power converters. So if it is goes to a DC to AC, is called as an inverter. So DC to DC, it is a chopper. AC to DC, it is AC to AC. So it comes two part. One is cyclo converter, another one is controller. So this entire closed loop, that is one circle, it gives an entire converter topology scenario. So then types of power converters used for electric vehicles. So that is very important. So this green selected for a battery operated electric vehicle, and some of the topologies are not suitable for electric vehicle. So take as a isolated or non-isolated or a broad category of DC to DC power converters. Why we have to focus the DC to DC power converters? In the sense we have to boost battery power for a particular extent. So for that we have to focus the DC to DC converter. For that interleaved multi-port and isolated is a bridge jet source, that is impedance source now is under research. Now it is in implementing with a jet source inverter, and it is a multi-port. So if you take as an interleaved, it has a boost, and if you take as an isolated, that have a full bridge. So this is a wide area what type of converter we have to select that. Then as an electric vehicle, broadly it has two. One is high voltage, another one is low voltage. If you are dealing with a 48 volt, so directly we can make it as a bidirectional DC to DC converter. If it is moving with a high voltage energy system. So it we can't make it as a bidirectional. So that is an inverter system for traction motor. For example, if you take as an induction motor drive, it is very difficult to, if you are operating with a high voltage, it is very difficult to accommodate as a regenerative braking operation with a particular extent. So likewise, so we can make it in a similar manner. So this, I hope you are all visible. So in the first category, it is a battery bank, DC to DC to AC. If it is an induction motor drive. So that comes under a single induction motor drive with differentiator. Then B, diagram B, battery bank with two induction motor drive, which is connected with the left and right. So these are all some category we can design. So based upon a requirement of a customer, each and every vendor, they are now in a full-fledged manner to develop electric vehicle in a sophisticated manner, like that of an IC engine. Then if you want a four-wheel, so it needs four induction motor. Each induction motor is connected with an each wheel. So that is C. Then if it is with a super capacitor for particular occasion, so for particular connected with it with a super capacitor. So in that case, we can directly move to a super capacitor. So super capacitor, it is connected with a DC to DC converter. Then again, if you need a battery bank is D. Diagram D is in addition in added with the DC to DC chopper. So it has two DC to DC. DC to DC for battery, another is for capacitor. Suppose if you want to make it as a super capacitor with a solar cell or some other concept or fuel cell, whatever it may be a system, again it means multiple input system. So battery bank acts as one system, super capacitor acts as another system, and fuel cell acts as another system. So automatically these if you want to develop an electric vehicle, so which may comes under any of these six diagrams. Equivalent circuit, maybe a diagram or equivalent circuit, whatever it may be called. So starting with a single induction motor to three induction motor, likewise we can make it. Then high frequency power converters. This comes under a separate area. So if we make it a high frequency, why we go for a high frequency? Another question. So high frequency, it goes with a high switching frequency for a sudden boosting. Voltage stress, if you want to reduce the voltage stress, we can go for a soft switching concept. So these are all frequency. So we may a device also nowadays available. So high frequency transformer to make a system most comfortable and also make to reduce the losses in a particular system. So likewise, we go for a high frequency concept. Then to take as a power converters, it has a major role, not only transmitting a power from a source to load, and also hybridization is very important. If you want to hybrid two or more power, simply called as a multiple input. So for this is a bidirectional system. For example, if I take as a first system is an power source, then converter. Then if you want to make it develop a converter for induction motor drive, then again we go for a variable frequency. Then if you are increasing, one more thing, if you are increasing a number of blocks, automatically each and every block, it has its own switching cost. If you are adding a single switch in a particular circuit, automatically theoretical approach, whatever may be a concept, while if we go for a practical approach, real-time scenario, definitely they have a switching losses, so efficiency will get affected. So for that only, each and every block we have to calculate analyze, that is efficiency. So here efficiency DC, efficiency VFD, efficiency of induction, that is electric motor, efficiency of a gearing transmitting medium. So likewise, so the power converters for EV, while selecting a particular topology or whether we are increasing a topology, we have to take an utmost care without sacrificing efficiency of a particular system. So for increasing a future, we are working, we have to increase futures in a sophisticated manner. So we have to take an utmost care without sacrificing efficiency of a particular system. So this is topmost diagram is for again. We already discussed about a regenerative power flow. If we transmit a power source to load, so we have to make such a system regenerative. So we have to develop this. If the system is under not in such a cases, entirely the regenerative power will not be appear. So regenerative battery charging of battery system through a regenerative is in absence here. So likewise, we have to develop such a DC to DC chopper in a suitable manner. Then we can make it as a bidirectional converter with a multiple input single output scenario. So if I take a system or that is wind or solar or power, whatever it may be, so we can connect with a bidirectional converter through a boost chopper. So that it will connected with a common DC link bus. So that is a very important case. Whatever may be a system, if it is a multiple input or it may be a double dual input, whatever may be, more than one input, it needs a common DC bus. So without common DC bus, we can't make a system in a sophisticated manner. So again, a bidirectional converter, it converts DC to AC. The DC to AC is connected again with that common DC bus. That common DC bus, AC bus may be connected with the DG like that. So in the electric vehicle, what are the power converters they have? So take as a ultra capacitor application. Go for a bidirectional DC chopper with a ultra capacitor electric vehicle, isolated bidirectional AC to AC converter for DC distribution system. So that is a common DC bus. Then again, battery charger. So these are the key power converters for EV. So take as an EV in features. So in order to achieve that features, we have to add a separate converter. So bidirectional T converter for EV applications, interconnect directional converter for plug-in electric vehicles, then direct conversion of an AC to DC plug-in. So multi-level. So nowadays multi-level inverters are moving forward to apply for an electric vehicle applications. Multi-phase. So these are all few application oriented power converters for an electric vehicle. So this and all I will skip it. So if I take as a market scenario towards the development of an EV, so it goes to a 40%. So up to a 2022 aggregate ratio, cumulative aggregate, so goes to a 40%. They have an increase. So one is for UPS system, another one is motor drive. So go for a motor drive and also go for an electric vehicle. So motor drive which includes conditioning. So it in turn comes to an electric vehicle concept. So both an electric vehicle and also want to increase the power factor. Again, they have a separate converter with a front end side. We have to make it in a clear manner. So this is the power density. So power density of a battery, supercapacitor, and fuel cell. So this and all plays a major role for selecting boost converter for a EV applications. Then if you want to choose a DC to DC chopper for a DC drive, simply they have a concept, the duty cycle 1 minus V by V out. So that is a concept of duty. That is T on by switch with an DC inductor plays a major role. So this and all So the boosting factor is decided by this inductor and capacitor. So this is a DC to DC converter. So this is a design parameter. So we want to make a chopper. We want to make a converter with a forward, reverse, and dynamic operation like that regenerative operation. Then we have to go for a four quadrant chopper operation. So four quadrant. So it has a four switch. So fixed DC to variable AC. So each and every quadrant they have a positive power and a negative power. So based on that, we can achieve motoring and braking operation. So dynamic braking is rheostatic braking. So that are they have a drawback. So in the electric vehicle directly we go for a regenerative braking. For that we can develop a four quadrant chopper in a multi-directional operation. Multi-directional is very important. So multi-directional converters or the apt converter for EV systems. So this is an interleaved four-phase boost DC to DC converter. So interleaved in the sense each and every we have to make it as a boost operation. So it doesn't need a separate boost. So this type of drive is directly connected with a BLDC motor drive. So efficiency comes under 92% for a 30 kilowatt of electric vehicle load. So for BLDC motor, we can go for a interleaved four-phase boost DC to DC converter. Then with the resonant switch, with the resonant converter. So if you want to reduce the size, automatically if the frequency get increases, automatically size of the components also get reduced to increase, to reduce the size and weight of heat sinks or what that directly we can go for a resonant converter. So resonant converter again one more converter part is get added. So DC to DC with the resonant circuit. So resonant this Q2 and LR act as a resonant converter. So automatically the short switching concept also interfaced with the resonant converters. So next one is full bridge DC to DC converter. So here they have a switching transformer. So have a H bridge. So it acts as an invert switching. It may be act as a four quarter, may be an inverter. So N represent the turns ratio. Turns ratio directly we can get a DC output. So if it is suitable for a BLDC because we are using an inverter concept and a backend, so we can choose this type of drive for a efficiency is 90.5% at a. So these and all from a research literature, not from any one data. So this percentage, everything which comes under a literature service of a IEEE, IET, Taylor, Francis, Elsevier, like that, they have a number of literatures nowadays available in a web. So if you want to design a particular drive for particular application, or if you want to make it as a EV to develop an EV projects, so you can utilize that. Then isolated ZBS DC to DC motor. So this comes under entire scenario. So if we want to make it as a zero voltage crossing to reduce the switching isolation transformer. So for that they have an 1:1 concept like that. So here, so ZBS concept is achieved through capacitors with zero voltage switching. So duty cycle or developed. So efficiency is 91.5 again and again. So go for a sinusoidal amplitude high voltage bus converter. So it has enough inductors are not having, so it's not suitable for a high power application. Power we can use that. So it comes under a sinusoidal type. Then multi-port DC to DC converter. Suppose if you are having a two different types of source, one is battery, another one is a supercapacitor. Interface through a bidirectional converter. So we can interface converter in a systematic manner, and we can make this in a we can interface with a backend converter. So without disturbing a backend converter, so we can develop a system in such a multiple input, single output converter. Then multi-device interleaved DC to DC bidirectional converter. So that falls under multi-component devices for a high power applications. If you want to make a system in a high power, So maximum power we can obtain for a high, that is a high power electric vehicle like a trucks like that. So we can choose a multi-device interleaved DC to DC bi-directional converters. So each and every device, each and every that is topology, they have a bi-directional concept. So specifications, value, so each and every devices, each and every topology, they have its own specification, how much we can take it as an output and input. So this and all data available in the web. So how many phases it's having, what about a ripple factor, what about an inductor current like that, what about a switching frequency. So likewise, each and every DC to DC high frequency converter, it has its own specifications and values. Then if you go for a power density in power electronic devices, so keep on increasing. So power density is getting increased. So power dissipation in a particular component, but if it is a thyristor valve, it has its own value. If you go for a silicon carbide, nowadays silicon carbide plays a major role for developing semiconductor devices to develop a particular converter systems also. So if it is a general purpose, it plays a major role. So keep on increasing with the thyristor devices and to silicon carbide. So this is a charging station with a common AC bus with a suitable converters. So whatever may be an infra, so it needs a separate converter for a single systems. So it may be an AC to DC or it may be a DC to DC. So frequency here determined by high frequency transformers. So charging station port 1, 2, 3, they have a number of ports. So direct, so it is connected with a common bus system. So we already discussed about a common bus. So if a system having a multiple input with a single output, it needs a common bus like that. Then if it is a inductor motor based induction motor based drive, so we can go for a AC, that is a DC to AC, that is an inverter. So it's a basic principle of inverter. So it converts DC to AC. So that AC is given to an induction motor drive. Suitably, it can make it as a particular manner. So whether it may be a spiral wave system or it may be a pure sinusoidal system. So if we go for a spiral wave system, so each and every H bridge switches activated time spiral wave. So same inverter automatically it gets working in a same working under the same topology operation, but composing it reduces the heat of a particular winding, so it gives a better performance of a particular drive. So it's a H bridge inverter. So each and every H bridge was get activated with the proper switching concept. So the system works plan accordingly. So is a equivalent circuit of single phase DC to DC, DC to AC. Here the boost concept is achieved through CF. That is through a capacitor we can achieve a boost concept. So if I go for a three-phase inverter, I already told electromagnetic field plays a major role in a three-phase inverter. A system it plays accordingly based upon a switching of a particular devices. The three-phase inverter is most three-phase induction drive and also for BLDC motor nowadays. Three-phase inverter-based systems are getting established for to get a sophisticated features. Then this is a performance of a particular converter with a DC to DC alone. So bidirectionality is one of the important parameter, efficiency, controllability, reliability, then power dissipation in a particular devices and multifunctionality. So these are all the features in order to make a system most comfortable, and also that reliability is very important. Efficiency, bidirectionality, reliability are the important key parameters. So each and every device, each and every switching converters, it has its own features. So we have to choose a appropriate device, appropriate converter for a particular application. So this is a three-phase induction motor drive, three-phase inverter for BLDC motor drive. So it has a Hall sensor at each and every shaft. So based upon a rotation, the Hall sensor produces output and it gives input to a decoder circuit. So based on that, the power converters will work accordingly. So the systems are developed in such a manner for a BLDC motor drive. So each and every each and every switches are get activated. So based upon an input from a Hall effect sensor. Hall effect sensor gets input from a SAT. Then another important developing area is a jet source inverter. So jet source inverter, it has its features of VSI and CSI. So directly we can boost without adding any switches. But only one drawback in the sense bidirectional concept is not achieved in that much in a jet source inverter. So if I take as a PV system, the output of PV is directly get boosted with the S1, S4 and S1, S2 like that. The switches are get operated in a shoot through or non shoot through manner, and automatically input power is get boosted. Then in order to overcome the drawback jet source inverter, they have an extended boost with a diode assisted extended boost jet source inverter. So here we can achieve a bidirectionality concept through a capacitor charging and discharging of particular system. Then single input dual output DC to DC. So this is important. So if we have a single input, but we need three output or many output. So why we have to select a system in such a case? So generally, if you take an electric vehicle, it needs two systems. One is one system for drive operation, another systems for wiring operation. That is wiring in the sense wiring for lights, wiring for battery backup, wiring for relay control, wiring for ECU unit. So that is entirely different. So it has two main ports. If you take as an higher end or any type of vehicle, the wiring system is in two different divisions. One is high power, another one is low power. The high power is for to drive a vehicle, that is connected with a drive with a switch. Another type of wiring system is for, so through a color indication we can directly identify what type of wiring system. So normally yellow they are using, black they are using. So this type of electric wiring specification gives a more important for a particular application. So for a particular system only for lighting headlight, for that system is not directly connected with the drive. So what I am trying to say in the sense, the main functionality of a particular drive should not be affected by auxiliary parts. So this is a single output, three output DC to DC converter. So they have a high voltage, middle voltage and low voltage, and some auxiliary with the clamping circuits. So if you are adding more and more components, definitely, so they have a decrement in efficiency. So no doubts at all. But if you want to increase the features without sacrificing the efficiency, so you have to take utmost care by developing a system in such a way. So this is a fuel cell based electric vehicle. So the fuel cell directly connected with the converter. Then converter is DC to DC is connected with an inverter system for induction motor drive. So automatically battery systems are placed accordingly for electric traction controller. So based upon a command received from each and every output, it acts as an input for a particular system. So this is a FC based electric vehicle. So this is an interlinked sources. So if we are having a biomass gas, so like that, so we can add as we can connect it with a fuel cell, and directly we can connect it with a battery. Anyway, we are trying to store an energy in a battery, charge in a battery. So automatically the battery act as a fuel for an EV. So which in turn connected with the connected with the through and converter for a wheel, that is SAT. So this is a EV powertrain. So EV powertrain. So it has supercapacitor concept. So supercapacitor concept is directly to meet a peak power demand. So it has a sudden discharge. So high power with a sudden discharge. In order to balance the starting torque of a particular system, so we can connect the supercapacitor with a particular drive systems. So another and all says remaining and all it is similar. So they have a three-phase induction motor, and also they have an onboard charge controller. So this comes under a four-wheel drive operations. So they have a propulsion battery for a particular fuel systems, fast charging converters and all. So this and all similar cases. So this is an entire block diagram of a particular power converter for a particular EV systems. Uh, so it has a battery charger and bidirectional converter. So if unidirectional converter also there, so that is what I told in the lighting purpose. So that is for wiring. So depends on application. In EV also they have a different application. First we have to what are all the components, what are all the systems required for a DC to DC converter, what are all the systems required for a high power high frequency converter. So we have to identify the system in such a way, and we have to plan a system so that if it is for a cooling fan application, for radiator control, it has its own application for DC to DC, and if we go for a power factor control application, so it may be go for an isolated, or it may becomes under isolated or non-isolated application. So like that, likewise, so we have to select in such a manner, and we have to make a system accordingly. So this is an experimental setup of a particular system. So it is a PV array with a boost converter. So boost converter with a H4 inverter, that is a H bridge inverter. So this is an experimental setup. So researchers, we can try with this experimental setup, and we can choose a particular converter for a particular drive application. Whatever may be a drive application, we can ensure that the converter is in dual, that is bidirectional or not. So we have to ensure that. Then we have to consider whether it comes under an auxiliary load or it comes under a main load. So it's another experimental setup. So power and electronics interface with an electric drive. So each and every component, each and every block, it has its own roles and responsibilities of the particular converter systems. So go for a control techniques is already, it is very similar to that of normal. Go for a, we can choose a PWM or whatever it may be. So another one is a wide band analysis, that is gap analysis. So this is very important case. So what type of band, where we are in a silicon or in a silicon carbide, or it is a GaN. So what type of material we are using, what technology we are adapting. So this scenario gives, this slide gives an entire scenario about technology, and along with what type of people, what we are using, what type of customers, what we are developing, using. So this and all comes under this slide. So I hope I have completed my presentation by on time. So if you have any queries, you can ask.
Participants, you can post your queries in the chat box, or you can unmute yourself and ask the questions.
Sir, can you come to slide number 37?
37. Yeah.
Sir, just
Am I right?
Just one slide back, sir. One slide back. The diagram, black diagram. This one, sir. Sir, in this, when PV module is connected,
Okay.
Is it audible, sir?
Yeah, audible, sir. Yeah.
Yeah, myself, Sai Krishna from Kochi Metro.
Yeah.
Yeah, sir. When we are connecting this PV module, we are using only the boost converter.
Yes, sir.
So remaining battery as well as ultra capacitor, we are using as a bidirectional converters.
Yes, sir. Yes.
So in this condition, how we are isolating in the regenerative condition? Regenerative condition, if it is regeneration happening, the battery will be charged in the reverse flow. But PV module, how we are isolating in this particular PV module?
So in a boost converter, they have an isolation process. So does
Okay,
it
it is
need
inbuilt.
so
It
boost
is inbuilt a boost converter only. It is
inbuilt converter? It does not need a bidirectional converter from a source to load. So but the PV system act only as a source.
okay.
So
Okay, sir.
for that purpose alone, only we are moving towards a boost converter in a particular case.
So it will take care of the reverse current flow. Is
Yeah,
whenever
yeah.
this yes.
Boost converter automatically it will take care.
Okay, okay. Thank you, sir.
Okay.
Thank you.
Thank you,
Thank
sir.
you.
Thank you. Thank you, sir. Thank you.
So I hope there is no queries. So we'll wind up the session. So on behalf of the management, CE, principal, HOD, and organizing team, I thank Dr. Uthirasamy sir, Associate Professor, Department of EEE, KPR Institute of Engineering Technology, for his more insight on the power converters and the types and how it is combined with the electric vehicles. So I hope everyone would have cleared with the idea of how the power converters are inbuilt with the electric vehicles. I thank I thank Dr. Uthirasamy sir for his valuable presentation. Thank you, sir.
Thank you, ma'am.
Thank
Thank
you
you
all.
for providing this
Thank you.
opportunity, Ms. Rajagation. Thank you, ma'am.
Thank you, sir.